Hello, everyone. Welcome back to CHM421 Analytical Chemistry. In this video, we will continue our lecture on topic 3, sampling and evaluation of experimental data. Under the subtopic evaluation of experimental data, on the last video, we're talking about three types of error, systematic, random inverse errors. So now we try to evaluate the experimental data using statistical procedure. In this video, we will focus on the mean, median, range, precise, deviation, accurate, and error. So what is mean? Mean or average. So X bar. This is the symbol of mean. Mean can be calculated by dividing the sum of replicate measurement by number of measurements in the set. So this is the formula to calculate the mean. The sum of the replicate divided by the number of measurement. So small exercise. Five students obtain percentage of chlorine in sample is follows. So they have five readings or five values. Calculate the mean. So what you can do is you have to do the addition, sum of this. Do the addition of this five value, and then divided it by number of value 5, 1, 2, 3, 4, 5, and then you can obtain this answer. So let's say 19.82 plus 19.57 plus 19.68 plus 19.71 plus 19.75 divided by 5, you obtain 19.706. So if you still remember the significant figures, how to decide the significant figures of additional operation. So from the calculator, you obtain 9, 10, 7, or 6. And then due to significant figures, we follow the lowest of significant figures, which is 4 significant figures. So result, your answer it should be 19.71. These are 4 significant figures. Okay. Median. What is median? Median is the value that is in the middle of set of data. So median of set of replicate data is the middle result when the data arranged by increasing in size. So you have to remember the data should be ordered in increasing order. So again, same example, 5 students obtain a percentage of chlorine, 5 results. So find the median. So you have to arrange this value in increasing order. So from the lowest to the highest. The lowest one is number 1, and then number 2, number 3, number 4, number 5. So the middle data, it should be number number 3, which is because we have 5 values, so the result the middle data, it should be in the number 3 data. So the result 19.771. Okay, range. Range the highest value minus with the lowest value. Using the same result, using the same question, we can calculate the range. So the lowest, this one, and then the highest, this one. So if you use the calculator, highest minus lowest, 19.82 minus 19.57. So 0.25. Okay. All right. Precision. Precise. Precise meaning that how close the measured value to each other measurement. So meaning that how close the measured value to other value, the other measurement value that have been made in exactly in the same way. So this precision is described the reproducibility of result. It can be expressed in terms of deviation. So if the deviation is small, so meaning that the analysis precise. So this is the chemical, this is the formula to calculate the deviation. Precise related to deviation. So deviation, value obtained minus mean. Okay. So value obtained minus mean. So mean, if you still remember, mean it should be summation of xi divided by n. Okay, xi divided by n. Okay, so mean value. Okay, accuracy. Accuracy is how close the measured value to the actual value. Just now, precise is how close the measured value to another measured value. Accuracy is how close the measured value to the actual value. The actual value, sometimes we call it true value or expert value. So it can be expressed in terms of error. So if the error is small, it indicate the measurement are accurate. So it can be reported in percentage error or relative error. So error, how to calculate the error? The value that obtained minus with true value. So true value, actual value or expert value is a same thing. Okay, this diagram is show you to make sure you understand what is the difference between accuracy and precision. So the first case, a few data scattered on very different location, far from the mean value. The middle one, the red point, we call it mean. Sorry, the middle one, we call it is a mean value. The mean value is related to the what is it's not mean value. This one, sorry, it's not mean value. This one is the true or actual value. Okay, so if you get the data, your data is scattered very far from one to another, meaning that is low precise and also low accurate. If the data uh, are located nearby together, meaning that is high precision. However, this is very far from the actual value, so meaning that is low accuracy. So if your data around the actual value, but located far from one another, so meaning that is low precise but high accuracy. The last scenario, all the result, all the data analysis come together on the actual data, so it indicates high accuracy, high precise. So, for example, if you playing a soccer and you always hit the lift goal post, but you're not scoring, so it indicate you are not accurate, but you are precise. Okay, because you are not scoring but always hit the lift goal post, so this one is precise, more precise, but you're not scoring, so meaning that you less accurate. Okay, so now is error. Error is related to accuracy. Absolute error, the value obtained minus the true value. This is the absolute error. Value obtained minus true value. Relative error, the absolute error. This one is absolute error divided by true value. Relative error from the mean, the value obtained experimentally minus mean divided by mean. Percent relative error, the relative error, absolute error divided by true value times 100%. So 1% error meaning that 1 part of 1,000 or 1 part of 100 or 10 part of 1,000. So meaning 1% error. So some very simple exercise. The result of analysis are 36.97. So this is the experimental result compared with the accepted value. So this one is true value. What is the relative error in a part of per thousand? So relative error is true experimental value minus true value divided true value times 100, but that one is 1,000. So you have to 1,000%. Okay. So by using the formula, the experimental value minus true value divided by true value times 1000, part of 1000. So, sorry, I think it's wrong. Oh, it's the wrong one. 36.97 minus 37.06 and then divided by true value uh, times 1000. So minus 2.4284. So for significant okay, you obtain 2.4 ppt part per 1000. Okay. Minus 2.4 to 8. This one is yeah. Okay, so you can obtain minus 2.4 ppt. So this symbol indicate part per 1000. This symbol is indicate part per 100. So this one times 1000. This one times 100. So you can try this exercise. The answers is given. This is the experimental data. This one is the true value. Okay, this one is xt. So you have to calculate the mean. Mean is x summation of x divided by n. So you can try. Median, it should be middle value. Division should be division is related to precise. So division experimental minus mean, if I'm not mistaken. Division experimental minus mean. So you can try division for trial number 3. Okay, trial number 3. Percent relative error, you can try relative error experimental result true result minus true result percentage times percent. Absolute error x minus xt. Okay, so you can try this one. All the results are already given in pink in color. Same goes to this exercise. I think it's the same thing. It's asking you to calculate the mean, median, deviation, For second data, percentage relative error, and also absolute error. So you can use the same formula that we learned on the previous slide to obtain the result. So the result given in the record. So all this is the result. So you can try. Okay, I think that's all for this video. On the next video, we will continue on the mean and also standard deviation. Okay, thank you. Bye bye. See you again on the next video.